Moving ahead, we have one more credible theory which ultimately become a significant base for Big Bang theory as far as the dark matter or interstellar matter is concerned, being a central idea of Big Bang. All right, let's begin with this. So we have this Schmidt's interstellar hypothesis. Now, in this particular interstellar hypothesis, in the previous theories, you have seen that there was a collision. There was a near collision, not complete collision, but there was a near collision based theory. Here in this interstellar hypothesis, there has been a mentioning about the gradual process. There is no near collision condition or no near collision based theory. There are some gradual processes, and these gradual processes led to the formation of our space, or let's say led to the formation of our solar system, including our Earth. So as per this particular theory, it has been mentioned that sun was formed before planets. Sun was formed way before than the planets. Galaxy contains region of dense dust and gas clouds. So this is what the assumption. Two assumptions are there. Sun was formed and galaxy, or let's say the space which is there, so that contains some sort of dense dust and gas clouds, similar as that of nebula hypothesis. I hope you remember. So this is being known as what? Interstellar matter here. So this interstellar matter, the new term is actually used with the old items. Packaging is new basically. So interstellar, or let's say interstellar material or interstellar matter is what? The dense dust, gas clouds. They are being primarily termed as this interstellar matter. Sun's gravitational pull can capture and retain the part of interstellar. Now let's have a deep dive this. First of all, as you know, sun was actually being formed way before the rest of the planets. So there was a sun, especially rotating sun, and there was randomly distributed interstellar dust or interstellar material, which is also being known as dark matter. So this sun, and we have a dark matter or interstellar dust. Now sun was orbited the galactic center, means the center of galaxy, the galaxy, means here you can say that our this Milky Way galaxy, and sun was actually being orbited around the Milky Way galaxy. And yes, while sun was actually revolving around the Milky Way galaxy, there was also dense clouds of dust or interstellar material which was there. So here you can see these dots are actually the interstellar material. So when the sun was actually revolving around the Milky Way galaxy, or when the sun was orbited the galactic center around the Milky Way galaxy, it passes through dense cloud, or let's say interstellar material or interstellar matter, interstellar gas you can say. So this gas and dust plus sun, there was an encountering of these three. As a result of this, what happened, that the sun's gravitational pull captured gas and dust, and sun became enveloped in this new cloud of matter. Sun captured the dust particle, and yes, it was surrounded by the same interstellar material. With this, what happened, that when the sun actually captured the interstellar material, it began to orbit the sun. Interstellar material, it started to orbit the sun. This interstellar material started to orbit the sun, especially in the diffused interstellar material as well. It's due to the sun own rotation motion, the sun gravitational force were further pulling the cloud inward, and due to the angular momentum, now the interstellar material which was irregularly being spread in the space, now that is being organized in terms of a particular disk shape, you can say. And this was basically because of the three set of forces. The three set of forces were there, and because of the three set of forces, the interstellar material was actually appeared in terms of disk shaped cloud. And as a result of disk shaped cloud, later you get to know that the planets were about to form, or let's say planets were actually. So within this rotating disk, here we have a disk. So within the rotating disk, particles of gas, or let's say interstellar material, they began to redistribute, or as a result of this, what happened? The denser material which were there, the denser material moved towards the center, while the less denser material were actually on the outer part of this disk shape, on the outer part of this rotating disk. So denser particles towards the center because there was a hotter regions, and the lighter particles were pushed away from the center, or let's say on the outer part, outer portion of that disk shape. Now the further the process of accretion, means collision, but thickness towards each other was happened, and as a result of this, the smaller bodies were combined together. As a result of this, the bigger bodies were actually emerged. So here we have a accretion, the process of accretion, and as a result of accretion, there was a further proper orbiting around the sun. As you know, as a result of accretion, what happened? The planetesimals were becomes larger, and planetesimals continuously they absorbed the accrete or nearby matter and growing in size, and becomes what? Planets, especially inner planets and outer planets of our solar system. Planets, if you see, even with respect to the density, so this aspect of center part, those who have a more density, and the outer part of that disk, those who have a less density. Now that is being justified when it comes to the outer planets and the inner planets of our solar system. Inner planets are more dense as compared to the outer one. Okay, so this theory is having some sort of scientific observation, scientific justification or validation, that to some extent it is credible, it is validated. So planets formed, they grew continuously, and then the dust and gas further condensed, and when the particles which were remain left, the small rock blobs which were remain left, they were actually become the satellites of the planets. So the bigger planets which were there, around them we have some smaller planetesimals, and yes, this theory also justifies that how there would have been the natural satellites of the different respective, that has been justified by this Schmidt's interstellar hypothesis. Further, the uncollected material which were there, which was actually not the part of this disk shape, that ultimately led to the formation of asteroid belt or comets or Kuiper belts, you can say. You'll have a more clarity in some upcoming slides. So this is how the solar system, including Earth, have been formed. It's a different theory, might be having some sort of pinching in your mind that we have so many assumption here. Yes, we have so many assumptions. Here we have a crux. So see, sun was formed first, and the sun was actually passed through interstellar cloud. Interstellar cloud was comprised of dust, and cloud was comprised of cosmic dust, was comprised of gases. So when sun was encountered with the interstellar cloud, it started to capture the interstellar dust or interstellar material, you can say, that capture by sun, and as a result of capturing by sun was enveloped around that dust. Energy loss was there, settling was there, disk formation was there, planetesimals were there, accretion was the further process, and planets were formed as a result. Though this theory is credible, it's being backed by some sort of modern day scientific observations as well, but it also owns some sort of limit. So this capture efficiency, first of all, that when the sun was encountering with the interstellar material, so how it captured the interstellar dust or interstellar gas, that efficiency of sun is actually, or let's say it was not that much justified or credibly justifies in this particular gas escape is another we can say limitation, like the previous theories as well. Similarly, angular momentum was not fully solved, and yes, the origin of interstellar material, that how this cosmic dust or these cosmic gases were actually being there, assumption becomes limitation. Yes, so origin of interstellar matter is also one of the limitation of this theory, which was actually not justified, though it was actually the significant factor to explain